We are in session 4.2 now, and we have 14 papers to be presented in this session. Each participant will have 10 minutes to present their works. Our first paper is Deep Reinforcement Learning of Position and Velocity PID Control for Rotational Wing Unmanned Aerial Vehicles. Angelina Kim will present. If you are ready, you can share your screen and start your presentation.
Hello, everyone. I'm Angelina. I'm in California right now in the United States of America. And today I will be presenting on the deep reinforcement learning of position and velocity PID control for rotational wing unmanned aerial vehicles. Here we go. Okay, so this is going to be the outline of my presentation today. First, I'll be going through an introduction, then discussing more on the configuration and setup of the project, specifically regarding the PX4 software in the loop and the DRL engagement with PID controller, along with the DRL mission controller procedure. Then I'll be discussing my results with the static PID controller baseline performance and the DRL engaged PID controller performance, specifically regarding the DRL mission controller performance and the PID behavior under DRL engagement, and finally the conclusion and analysis of my results. So first, a brief introduction. Deep reinforcement learning network has been applied to the control of unmanned aerial vehicles. Previous research has utilized DRL to replace traditional proportional, integral, and derivative controller loops. This study deploys DRL at mission controller to adjust position and velocity PID controllers and flight controller of rotational wing unmanned aerial vehicles to improve mission control performance. It is equivalent to an online tuning of front end and low sampling rate PID controllers in real time to achieve a desired performance. So here we can see are some commercial jet fleet accident statistics from the Boeing company. The takeoff, initial climb, final approaches, and landing phases account for 67% of accidents with 6% exposure time. Though these are limited to fixed wing and manned airplane statistics, the goal of this study is to resolve these issues with a rotational wing unmanned aerial vehicle through dynamic control and performance improvement at these 4 phases. So the PX4 software in the loop. The PX4 Autopilot is a RWAV platform and is under the software in the loop. Gazebo Physics Simulator provides environments to PX4 RWAV, and specifically the wind plugin supports the random wind, which is what I used in my study. The mission controller is a custom Python code with or without DRL network, depending on the specific case. And the Q ground control is an optional visualization and monitor tool. All event elements are connected through the micro aerial vehicle link, or the MAV link. So as you can see in the middle of this slide, there are some telemetry data. The 50-point telemetry data set was transferred from RWAV to mission controller through MAVLink messages and includes inertial measurement unit gyroscope, attitude, estimator, and servo output. Values are normalized to -1 to 1 range as an observation vector to the DRL network. Dataset is uploaded at a 10 Hz rate. The DRL engagement with PID controller. So the reinforced TensorFlow agent implements the DRL network at mission controller. The DRL network accepts telemetry observation data as input, generates action space with position and velocity controller coefficient ranges, and then updates the position control and velocity PID controllers through MAVLink at 10 Hz rate. Position and velocity controller's rate is 50 Hz, and they are tuned in real time by the DRL network. So there are this is some more information on PID coefficients under DRL network tuning. The DRL network tunes position X, Y, and Z coefficients P sampled at 50 Hz. It also tunes the velocity x, y, and z coefficients p, I, and d sampled at 50 Hz. The rate and attitude controllers at 1000 and 250 Hz sampling did not show improvement from 10 Hz DRL network engagement, and the low rate 10 Hz tuning is efficient when onboard mission controller has limited computing capacity and power source, or remote mission controller has limited data bandwidth and latency. The DRL mission controller procedure. So first, the PX4R WAV is set as off-board mode. Actuator is armed. 50-point telemetry dataset message is requested. RWAV is commanded to hold position at 5 Hz. DRL has 5 inner layers and up to 400 nodes, and each training episode duration is 60 seconds, and there are 5 training episodes per each iteration. The learning rate is 0.0005. And as you can see in the reward function, the reward is inverse of distance and accumulated average distance with worst case distance considered. Performance is evaluated every 50 iterations, and each evaluation has 50 episodes, which are each 2-minute long. So as you can see here, this is a screenshot of my computer during the training. So right here we have the gazebo physics simulation with visualization. However, headless mode was useful to reduce computing resources. Right here, we can see the mission control Python code brings the RWAV through initialization, training, and evaluation sequence with checkpoints. Also, depending on the case, again, it has a DRL network. The training and evaluation start when the RWAV approaches target position, which is this blue line of 50 meters above the ground within 0.3 meters range. So the static PID controller baseline performance. Static PID controller RWAV is put to varying windy environments. Horizontal wind with random velocity and direction is applied to RWAV as force in gazebo. At each mean velocity, wind is set at 0.5 meters per second standard deviation and limited at greater than 2 meters per second than the mean maximum velocity. RWAV began to crash after 7 meters per second, so 5 meters per second is set as the maximum operational wind velocity. At 5 meters per second, average distance hold is 0.5 meters from 30 of 2-minute episodes. Now the DRL mission controller training process. The DRL reached 0.17 meters of mean distance after 6,050 training iterations. The plot on the left shows the mean distance from 30 of 2-minute episodes after each 50 training iteration. The solid line is the mean distance performance, and the dotted lines show how many standard deviations from the mean the drone's distance was. The total training and evaluation time is 525 hours. So you can see these are some telemetry data captured during the training and evaluation, and they give insights on the RWAV behavior under DRL network. The plot shows the distance changes over the last 2-minute iteration episode after 6,050 iterations. The worst case distance is up to 0.7 meters, as we can see here. And the RWAV achieved mean distance is 0.17 meters under varying wind through recovery effort from dynamic PID controller. RWAV trajectory under DRL mission controller. So this is the horizontal position trajectory from the last 2-minute evaluation episodes, and it shows the RWAV's horizontal response to the random wind. Vertical position doesn't really change significantly because the random wind is horizontal, and each point is updated at 10 Hz. The worst case distance is up to 0.7 meters right here, and the blue circle is the average distance of the episode at 0.16 meters. The red circle, on the other hand, is the average distance of the baseline static PID flight controller at 0.50 meters. So when comparing the static PID versus the PID under DRL, even though they receive the same position holding commands, there is a significant difference. The static PID case has a 0.52 meter average distance, whereas the DRL tuned PID performs significantly better at keeping target position. So now I'm going to be doing a demonstration. Here we go. Please let me know if you can't see the little video screen that I just pulled up. So right now, this is just basically a demonstration of the implementation of the program. So right now we're setting up the drone. This is the simulator. And now we're running the mission control. The drone's taking off. And it's trying to stay as close to the blue line, which is the origin, as possible. Okay, so now this is the static PID controllers. As you can see, the PID values are staying the same, and there's quite a bit of movement as the random wind pushes the drone. So you can see there's some distance increasing from the origin. However, for the dynamic PID controllers, which are constantly moving, as you can see here, the drone's overall average distance from the origin significantly decreases, and it's able to stabilize from the origin a bit more. Okay, so a performance comparison. As you can see in the table, the RWAV with static PID controlled had 0.50 meters of mean distance under average 5 meter per second velocity random wind. DRL engaged dynamic PID control at position and velocity control performance had 0.17 meters mean distance. Normalized standard deviations are comparable. However, the DRL network mission control improved position hold distance by 65%. Here is a graph of the PID coefficients under DRL engagement. So the position P and velocity PID coefficient tuning process right here. The coefficients, you can see they're almost always fluctuating, and altogether they're responding to worse distances like here, and are also responding to changing environments together. Additionally, when averaged across the whole episode, the coefficient maintains a flat level. So a conclusion. A DRL network in mission control was engaged with the RWAV's position and velocity PID controllers in the software in the loop. The DRL network was trained with 50-point telemetry data set at 10 Hz, and it updated 8 PID controller coefficients at 10 Hz dynamically based on the observation data. After 6,050 training iterations over 525 hours, RWAV's position hold performance was compared with the RWAV with static PID controllers under mean of 5 meter per second random wind. The DRL engaged PID controllers with 8 coefficients improved position hold consistency by 65% at a 0.17 meter average distance from 0.50 meters of static PID controller RWAV position hold. The DRL network modulated PID coefficients persistently to maximize position hold mission performance by exploring PID coefficient action space. This concludes my presentation.
Oh, okay, thank you very much for your presentation. Dear participants, do you have any questions about presentation? Okay, if there are no questions, we can go on with the next paper. The title of the paper is Vehicle Suspension Control Using Physics-Guided Machine Learning. If you are ready, you can start.
Is my voice audible?
Yes, we can hear you.
Okay. So good evening, everyone. My name is Anish Kurantiwar, and I'm a PhD candidate at the Center for Tire Research Lab in Virginia Tech. For today's presentation, I'd like to go over our research topic titled Vehicle Suspension Control Using Physics-Guided Machine Learning. This research has been conducted in collaboration with my colleague Utkarsh Gupta, who's also a PhD candidate at Virginia Tech under a research advisor, Dr. Saeed Taheri. So for today's presentation, the outline is structured as follows. I'll go over the introduction and what exactly is the problem statement that we are trying to tackle. Followed by this, I'll talk about the different kinds of suspension systems which are existing in the literature review, the different kinds of control algorithms, and how we plan to evaluate them and how we plan to enhance them further. Moving on, I'd like to talk about the test rig which we have in the lab, in which we implement different kinds of control algorithms for a damper in a vehicle suspension setup. Finally, I'll talk about the physics-guided machine learning framework which we have proposed and developed as a part of this research. Moving on, how we implemented different classical suspension control strategies as our baseline model, and comparison between this physics-guided machine learning framework and the classical suspension control strategies. And I like to end with the conclusions and the future directions in which we plan to take this research forward. So conventional classical suspension control strategies, which, for example, skyhook and ground hook control, along with the machine learning based controllable suspension systems, are completely data driven, which basically need to acquire the sprung and the unsprung mass data in order to optimize the damping coefficient. Now, these conventional control systems have the inherent limitations that since they are so much data driven, they cannot accurately change corresponding to different road profiles, the inflation pressures in the tire, as well as the different kinds of normal loads acting on the vehicle. And hence, in order to tackle this, we need a framework which combines the merits of both a data-driven approach and a physics-guided modeling approach. And this is where our framework comes into the picture. So before diving into the physics-guided framework, I'd like to give a quick overview on the different types of suspension systems which are available. Starting with the passive suspension systems, these are the conventional dampers whose damping coefficient cannot be changed and which are essentially the least complex subsystems. On the extreme other end are the active suspension systems, in which the damping coefficient can be variably changed by changing the damping of the fluid, or also with the help of a linear actuator, which changes the external force which is transmitted from the road surface to the sprung mass. However, the primary disadvantages of such systems is they're highly complex and they have an increased cost. And this is where the semi-active suspension systems come into the picture, wherein the damping coefficient can be varied in real time based upon varying the fluid properties through which the fluid flow through the damper. And the semi-active suspension systems are what we are focusing on in this research. So what we have in our lab is a shock dyno test rig. We've slightly modified this in order to collect the data corresponding to the sprung mass and unsprung mass by implementing 3 different single axis accelerometers. We've tested the damper at different velocities, which is given as an input from the base of the shock dyno test rig, different normal loads, and different valve openings. Each one of these different valve openings ensure that the damping coefficient of the damper changes. So this is a very small video demonstration of how the shock dyno test rig works, along with the different kinds of accessories and the electronic hardware setup, which is required in order to change the damping coefficient in real time and collect the accelerometer data corresponding to the unsprung mass and sprung mass of this quarter car test rig. And just to show the sample data which we got from the previous test. So the one in red shows the sprung mass, which is collected from the accelerometer mounted at top of the shock dyno. And the one in the gray is the acceleration of the unsprung mass. From the data, it is evident that the unsprung mass has a greater magnitude of its acceleration as compared to its sprung mass due to the damping effect of the damper present between the two. So finally, I'd like to talk about the framework which we are proposing here, which is a physics-guided machine learning framework. The entire framework can be classified into 3 different stages. The first stage comprises of a machine learning-based regression module. This is completely black box and it takes inputs in the form of an actual unsprung mass acceleration, which we get from the accelerometer mounted on the shock dyno. The damping coefficients, the normal load vector, as well as the input velocity vector. And the output of this regression model is the actual sprung mass acceleration data. The second stage of this model is where we try to induce physics into the entire black box machine learning with the development of a single degree of freedom base excitation model. Now, the inputs to this base excitation model are a desired sprung mass acceleration and the actual unsprung mass accelerations. And this is the desired damping coefficient we need in order to get the desired sprung mass acceleration values. Now, with the as soon as we get these desired damping coefficients, we input them to the pre-trained regression module and get our model-based sprung mass accelerations. Now, the error between these model-based sprung mass accelerations and the desired ones are essentially given to a very simple, finely tuned PID controller, which outputs the required and the most optimal damping coefficient value, which can be finally given to the shock dyno test rig in order to optimize the sprung mass acceleration. So now, I like to talk about the kind of physics-based model which we've implemented in this machine learning. So this is nothing but a single degree of freedom base excitation model. Now the base excitation model has been developed such that it matches the closest to the shock dyno test rig which we have in the lab on which the data has been collected. So it essentially comprises the single degree of freedom in this case, essentially the sprung mass of the vehicle, and the dynamics of the sprung mass have been encapsulated by this spring with a stiffness K and a damping coefficient with a damper C, which is in real life represented by the damper, which is mounted on our shock dyno test rig. So the first stage of our physics guided machine learning framework, which I talked about, was the development of the regression model. And the regression model took into inputs different unsprung mass accelerations, velocity vectors, and the normal load, and gave us outputs in the form of sprung mass acceleration. Now, we tried different regression models ranging from support vector machines to neural network regressions. Based upon our quantitative metrics of R-square and RMSE values, what we found that the neural network regression gave the highest performance, and hence we decided to choose this in order to predict the sprung mass accelerations. This slide shows the comparison between the sprung mass accelerations as we get from the actual experimental setup, which is shown in red, as compared to the one which we get in blue, which is from the neural network-based regression model. As it can be, we can see from this graph that the differences are minute in the range of 10 to the power minus 2. So now, with the development of this physics-guided framework, the next step was to develop baseline models so that we can compare the performance of this framework with the classical suspension control strategies. And for this, we've implemented two classical control strategies, which are skyhook control and ground-up control. Now, both of these controls are essentially on-off control, and they depend upon the relative velocity difference between the sprung and the unsprung mass. To give an intuition to each of these control algorithms, the skyhook control essentially assumes a virtual damper which is connected to the sky from the sprung mass. And the primary objective of this is to improve the comfort of the passenger inside the vehicle. Analogous to this is the ground-up control, wherein we have a virtual damper which is connected from this unsprung mass M2 to the ground. And the primary objective of this is to improve the road holding characteristics of the vehicle, that is, to improve the traction force between the vehicle and the road. Now, talking about the results stage, the entire results section can be broadly classified into three different stages. The first stage was to see how well the physics-guided framework can actually estimate the damping coefficient. And in order to get the estimates, the output from the guided framework was compared with that we get from the experimental setup. And what we found that this framework was able to predict the damping coefficient with an accuracy of 95.22%. The second stage, or the second aspect of the results, is actually evaluating the performance of the physics-guided framework quantitatively and comparing it with the baseline control strategies. And for this, we've utilized the metric of ride comfort. So what ride comfort essentially says is it gives us a quantitative metric of the amount of comfort which is felt by the rider inside the vehicle. And in order to evaluate the ride comfort, what is done is we convert the time domain accelerometer data into frequency domain, get its power spectral densities, and compute the average power spectral density by calculating the area under the curve. Smaller the value of this comfort cost, better is the ride comfort. And from these power spectral density graphs, what we found that the physics-guided machine learning framework had the lowest value of average power spectral density as compared to the other control algorithms. This can be better visualized in this histogram, wherein we can see that the comfort cost, which is given by the physics-guided framework, is nearly 96% less as compared to the other control strategies, indicating that such a framework gave the highest ride comfort. So to conclude, in this paper, a physics-based approach has been followed in order to tune the damping coefficient of a suspension system by integrating a base excitation model into the black box data-driven approach. Based upon the preliminary results, what we found that such a framework could accurately estimate the damping coefficient values, as well as give a better response in terms of reducing the sprung mass acceleration. The future scope of our research is to further develop long short-term memory-based recurrent neural networks, as the data is collected is a time series data. Along with this, we also plan to implement more advanced controllers such as model predictive control and H-infinity control instead of the PID controller to see how much of a boost we would get for our performance. Thank you so much, everybody, for your time, and I'll be open to answer any questions.
Thank you very much for your presentation. Dear participants, are there any questions about this presentation? Okay, I guess there are no questions. The title of the next paper is Design of Cloud Computing System for Home's Electric Energy Larceny Detection. If you are ready, you can start.
Assalamu alaikum. My name is Saja from Iraq. Today I will present my system, Design of Cloud Computing System for Home Electric Energy Larceny Detection, presented by Saja Abdel Hamza, Laith Ali Abdul Rahim, Salmat Ibrahim. Our system utilizing the cloud computing technique for data storage and specifically infrastructure as a real-time energy usage data is collected by Arduino and transmitted to the central database. In the cloud computing, ASP.NET Core framework is using to analyze the data collection and view and run the algorithm of larceny detection and show the result on a web application-based application. We have first introduction. The increasing demand for electric power has resulted in increase in the electric losses. The electric losses can be divided into two branches, technical and non-technical. Non-technical is represented by electricity theft, which is a significant problem for utility companies, which can represent by meter tampering, illegal load connection, direct hooking. We have to use cloud computing in the smart grid. Which a smart grid concept has been developed to address efficiency, reliability, and security challenges in power grid. The smart grid generates a large amount of data through its sensors. This data, cloud computing be the solution for storing this data and processing and analyzing. Cloud computing overcome the cost and benefit challenge faced by early smart grid. We have a lot of multi models and services for cloud computing. The cloud computing provides over various services to meet the varying requirements. Such as infrastructure as a service, platform as a service, software as a service. In our system, we suggest to use the infrastructure as a service for security and because the organization only have this server. And in addition to this servers models, there are different cloud deployments, namely private cloud, community cloud, public cloud, and hybrid cloud. Why we use cloud computing in our research? Cloud computing, specifically infrastructure as a server, can be a great solution for utility companies. IA infrastructure as a service providing necessary infrastructure for storage, analysis, and network offers a private model for utility companies. The flexibility and scalability of infrastructure as a service can handle the increasing data generated by smart grid. Security and physical location maintenance and upkeep of equipment are handled by cloud service providers. The cost of infrastructure as a service is more affordable compared to the local service. Cloud computing technology.
Sorry, just a minute. We cannot see your presentation. Are you changing the pages in presentation? We just see the entry page of your presentation. We can't see the other pages that you are mentioning.
Sorry, I don't understand.
We cannot see your presentation. We only see the first page of your presentation, the title of the presentation, and we cannot see.
Sorry bro. ست سجاد قلت لك انه السلايدات مالتك ما تشتغل ما تتحرك.
Okay. Thank you. You can go on.
Okay.
Yes, please go.
Now.
Yes, we
No.
can see you. You can go on.
What about now?
You can start again.
ست سجاد يقول لك انه استمري اقري يعني كملي.
The proposed system. The proposed system depicted in the figure below, which consists of 3 layers: hardware layer and cloud layer, user layer. The hardware layer smart meters to collect real-time electricity consumption. While the cloud layer is used, which is represented by a cloud server, used to run the algorithm of electricity theft algorithm. While the user layer is represented by a web-based application to monitor the electricity usage data. The hardware layer is represented by a smart meter, which is a component isolated in this figure. The component is Arduino Omega Wi-Fi, BZTM 0040, and LCD. The Arduino Omega Wi-Fi BZTM read all the data of electric parameter using and send it to the Arduino Omega. The Arduino Omega processing the collected data and send it to the ESP module through serial connection. The ESP module then sends the data to the cloud server using HTTP/STCP request protocol, with a transmission rate of 1 request per second, subject to the internet speed. This is the workflow chart of the system. First, we read all the electric parameters using the sensors. Then the Arduino Omega board sent the data to ESP through serial board. The ESP sent data to the cloud server using HTTP, which provide more security and communication type. The update, then the data is updated to SQL Server database using ASP.NET Core and C#. The data is processing is retrieved from the database by SQL through the SQL query and the entity framework. Then the electric larceny detection algorithm is running at the server. If there is a larceny data display, if there is the larceny data display with the notification, with alert notification. If there is not data, just display. This is the implementation of the system, which consists BZEM004T sensor, Arduino Mega, and LCD. We have this the mathematical model using to detection the electricity is first we divide the residual area into multi-sector. Each house should have a smart meter to monitor its power consumption. Additionally, checkpoint meters are installed after each group of houses to record the power readings. The mathematical model used to compare the total power contribution at the checkpoint with the sum of power contribution reading from each house. We have this mathematical. Sorry. This equation is represent the power contribution for checkpoint meter, which is the summation of power contribution for each consumer plus the technical losses and measurement errors and power thefts. This is represent the power theft. The power theft can be used, can be expressed as the reading of checkpoint meter minus the summation of power contribution for each consumers and the technical losses. If the power theft is greater than 0, it indicates the presence of power theft. Discussions. We say that the area is divided into multi-sectors, and the central checkpoint meter are installed to measure the total power contribution of each sector for theft detection. The detection process involves sequentially check each sector starting from the first to accurately identify instances of theft and minimize the impact of logarithm of the consumer. The implementation of the theft detection system using cloud computing, specifically infrastructure as a service, has been successful in detecting and preventing theft. The web-based application is to authorize the monitoring interface. This is the monitoring interface is used to track the real-time data electric parameter readings for the central checkpoint and individual households. The green indicator represents normal power usage, while the red indicator is activated when an energy larceny is occurred. This is the interface for monitoring the power electrical parameters. We have the voltage, current, power, energy, power factor, frequency. This is the node number of house 1, house 2. We have this. The system was tested in the following scenarios. First, we have normal power contribution where no larceny. if the difference is below, if the difference of the power contribution reading from checkpoint meter and the individual reading and individual customers reading is below than the predetermined threshold value, it indicates normal power contribution. This is the first case. The second case where by direct line topic.
Sorry, your time is finished. Please finish your presentation. Your time is finished, okay?
The conclusion, the implementation of a proposed electrical larceny detection system using cloud computing technique has been successful. Smart meter installed in each house enable real-time monitoring of electricity usage to provide accurate data for analysis. The system is capable for detecting various cases for electrical theft, including meter tampering, illegal connection, and transform timing. The web-based application offers real-time monitoring of electricity usage and provides accurate data for analysis. Thank you.
Okay, thank you very much for your presentation. We are going on with the next paper. The title of the paper is Computer Mathematical Support for Analytical Assessment of Stress in the Ukrainian Grain Market Development. If you are ready, you can start.
Yes, thank you. Congratulations to all participants. I am happy to join you today, and I would like to express our gratitude to the organizers for providing us with the chance to present our research findings at the Congress. My name is Victoria Shlikova, and I will present our research with my colleagues Irina Serova, Irina Aksionova, and Tatiana Milevskaya. Building a developed society in any countries in the world is related to its participation in global integration processes. The market of agricultural products is an integrated industry of the world market, which is characterized by a high degree of globalization. Agriculture is the basic factor of the Ukrainian economy that determines the level of its stability. And over the last decade, agriculture has been increasing production volume, thereby determining its contribution to gross domestic product. One of the leading industries of agriculture in Ukraine is grain production. The issue of disparities and imbalances in the national economy, the depends of the national economy on the situation of the world market and are related to the policy aimed at its openness. Reasonable openness of grain market is based on a combination of the principles of efficiency, competitiveness, and national security under conditions of variation in the export structure. Despite a rather wide range of research taking into account the relevance and practical significance for Ukraine, the process of forming of analytical basis for research in the grain market requires a relatively unambiguous solution. So the purpose of our research is the analytical summarization of data on the state and trends of the development of the grain market in Ukraine, and the comparison of these trends with global trends and the justification of the impact of the export of grain crops on increasing the level of competitiveness and economic growth in the country. The analytical evaluation was carried out using the Microsoft Excel software package to process data arrays, and the research was mathematically supported by a system of indicators, which included coefficients for measuring the openness of the economy for grain crops, export and import quotas for grain crops, net grain export, the international competitiveness of the country in the grain market, etc. As can be seen from the table on this slide, the structure of Ukrainians' gross domestic product over the past 12 years is mainly formed by the agricultural sector, the products of the manufacturing and the service sector. At the same time, there is a clear trend toward an increase in the share of agricultural sector in the structure of GDP. Grain crops are one of the most important and strategically reliable agricultural crops in the world, on the production on which the food security depends. According to data from 2021, about 97% of grain production in Ukraine was formed for the account of three main crops: wheat, corn, and barley. At the same time, corn accounted for 49% of grain production, wheat 37%, barley 11%, and the rest only 3%. And the share of Ukraine in world wheat production is 3%. The high production and export potential of Ukrainian agriculture for international trade is facilitated by the fact that the country has the most favorable conditions for growing grain crops, as evidenced by the data in the figure 1 on slide. From this figure, it can be seen that during 2010 to 2021, the same trends are observed in change of acreage for agricultural crops in general and grain crops in particular. It should also be noted that the specific weight of areas under grain crops in the largest among all agricultural crops, it fluctuates at the level of 65 to 68%. These trends are accompanied by an increase in the gross collection of grain crops, which is interconnected with the change in the structure of demand of the world grain market. The dynamics of change in the main macroeconomic indicators of the world grain market are shown on the next figure on this slide. And as can be seen from this figure, for the period from 2010 to 2022, demand and supply indicators on the world market of grain crops reflect a steady growing trend. And since 2018, there has even been a coincidence of demand and supply volumes, which confirms the growth in demand for grain in the world and characterize this product as one that strengthens the competitiveness of the country that produces and exports it. At the same time, we see that a trend towards an increase in grain stocks, which will have a positive effect on national grain exporters, as competition for sales markets will increase, as will the level of grain price volatility, which will accordingly affect the interest income. The conducted studies show that in the current condition of the development of the world market, among the exports of agricultural products, the largest specific weight is the export of grain. To assess the situation of the grain market in Ukraine, it is advisable to consider the dynamics of national production and export of grain crops. As can we see from figure on this slide, the export and production of grain in Ukraine are interconnected and have almost the same development trends, except for period 2012 to 2013. In addition, the export of grain crops has a constant upward trend, even in years when the production of these crops decreases. From the next figure, it can be seen that the trends in the country's total export of plant products and export of grain are the same, which confirms the importance of growing grain crops for international trade. In 2022, Russia's large-scale invasion of Ukraine changed the trend toward a decrease in export volumes compared to the previous year, but did not change the general paradigm of the importance of grain export for increasing the country's export potential. This statement is emphasized by the analysis of the export structure by years. On the next slide, we can see that in the structure of Ukrainian's export, the specific weight of export of plant products varies from 7.8% in 2010 to 30.5% in 2022. The specific weight of grain export is from 4.8% in 2010 to 20.6% in 2022. And the export of grain crops is important not only for the economy of the countries as a whole, but also for the well-being of national agricultural producers. Since Ukraine consumes only 30% of the grain produced and exports the rest to the world market. Ukraine supplies grain to most regions of the world, with the exception of America, Australia, and the countries of Eurasian Economic Community. And the total of grain export market in which Ukraine currently operates is about 130 countries. In order to evaluate the openness of the Ukrainian economy, the direction of grain trade, which contributes to the increase of competitiveness, national security of the country, and has a stimulating effect on the economy of the country, it is proposed to use the following system of indicators of the openness of the economy by grain crops and special criteria that they must satisfy. So we can see
sorry, your time is finished. Please try to sum up and conclude.
Okay, thank you. So more detailed information about result of this calculation and analysis you can find in our article. And let me conclude. First of all, analytical assessment of Ukrainians' position on the global grain market has proven the need to further increase potential in this field, as the grain market of Ukraine is deeply integrated into the global agricultural market. Ukraine is one of the 10 leading countries of producers and 5 of the leading countries of exporters of grain crops, which gives the opportunity to occupy the significant position in the international market. The second one, the system of economic openness indicators for grain crops proposed in the study is an effective tool for comparative assessment of the degree of the country's economy openness in general and by grain crops in particular. The conducted study of trends in the development of the grain crops market of Ukraine in global measurement showed that for a long period of time, the country supports the trend of increasing the production and export of grain as a product that meets international demands. And thanks to this orientation of export activity and support of the stable position of the country and its producers on the domestic and foreign markets, Ukrainians' position in the international competitiveness rating is insured, and at the same time, the real incomes of the population and businesses are supported and increased. Thank you all for your attention, and I am ready to answer the questions if you have any.
Okay, thank you very much for your presentation. Dear participants, are there any questions? Okay, if there are not any questions, we can go on with the next paper. So the title of the paper is Distributed Optimization Algorithm for Resource Allocation in MIMO Network with Intelligent Reflective Surfaces. Are the authors here? I guess they are not here. Let's go on with the next paper. The title of the paper is Data Mining Management System Optimization Using Swarm Intelligence.
Yes, I'm ready.
Okay, if you are ready, you can start.
Okay. Hello, everyone. I will be introduce myself. My name is Isra Ahmed Hassan al-Mashhadani from Iraq, master student in Altenburg University from Iraq. I am going to present my work, which is sorry.
Ms. Isra, continue.
Which is my title, Data Management System Optimization Using Swarm Intelligence. The main point of problem statement, which is data mining can have several trends depending on the types of data processed, such as text mining, web mining, and medical data mining. However, the users of the initial data mining system are also interested in their associated technologies and will be all the more so since most of these initials will have to be updated in the future as developments occur. Can appear at the level of the systems studied or in databases or data warehouses, which are constantly changing over time. The introduction. In recent years, the use of data mining techniques has grown very rapidly, where it has become vital in the practice of companies and people. In this slide, the figure for data mining process step, the one-step data cleaning, data integration, and data selection. Step 4, data transformation, data mining. For Step 6, knowledge representation. Motivation and aims. Business intelligence allows the explosion of an organization data in order to related discussion making. It has experienced and continues to experience today a significant boom. Individual information system were simply intended to produce data. Also, one of the objectives of data warehouses was the transformation of this information system into discussion-making system by transforming production data into static information. This figure in this slide, the dynamic classification problem in data mining. Contribution to solve the above problems of obtaining the necessary data set for a data mining study through dynamic model. We propose a solution based on system modeling using the data-based models. Social work is agent-based swarm modeling and adapted to model many complex dynamic systems, especially these that include automatized individuals like human societies, animal societies, or collaborative robot and insect societies. In this slide, the figure for diagram of the proposed system, data mining or artificial intelligence for technique swarm of intelligence, practical swarm optimization, and K-means and artificial neural network to evaluation. Swarm intelligence or collective intelligence refers in this way to property of
I guess connection is lost.
Sorry, the third is cutting the electric. I am Ali Sadun Ahmed, third other for the paper.
sorry,
You can share again.
can you again?
اوكي ست اسراء شيري مره ثانيه. اوكي واستعجل يعني سريع.
Okay, you can go on.
واضح؟
Yes, please go on.
Yes. Continue, Mr.
Continue.
تمام. This slide, the figure for biological swarm intelligence. Practical swarm optimization. Practical swarm optimization is a technique developed based on a biological spatial model and envelopes and learning and seeks to simulate the behavior of bird and frog. The practical swarm optimization has its original. This slide is the figure for some practical swarm optimization. And I've put for topologies. Neural language processing is one of the field of artificial intelligence that studies communication between human and computer. Neural language processing does not aim to transform the language received in the form of sound into digital data and or vice versa. Rather, it aims to understand the meaning of a give text where writing in a neural language format and provide appropriate response, for example, by performing a current action or displaying current data. In this slide, the figure for two branches of data mining. Dimensions reduction. This concept refers to the process of reducing the number of random variables considered and can be future subdivided in future selection and future extraction. The key is to reduce the number of dimensions but retain most of the information. The convergence associated with multivariate data analysis with the dimensions, that is the number of variables, is too large. The result future selections and transformation is one of the most important techniques and is often used in pre-processing data mining, especially for knowledge discovery and discovery science. These techniques reduce the number of future involved in data yet remaining target class value, reduces relevant redundant future and data that causes misunderstanding of the target class, which has an immediate effect on the application. As a result, data mining applications can be accelerated, enhancing the mining performance, such as forecasting accuracy. A future selection is a process that selects as selected a subset of original future size. The main task in future selection is to dynamic which futures are selected and used in the context of forecasting future attributes. A future is considered related when it is value varies similarity with category membership. In this slide, the figure for
Sorry, your time is finished. Please try to conclude.
Tamam. Just conclusion. Counseling. This research can provide an extensive application of future selection and emission education methods, in addition to view applications that have been developed more recently. It is becoming more vital to refine these technologies so that they can be used to the processing of very large moments of data. The researchers seek to use the big data setting to carry out their test and then assemble the results of this experiment into auxiliary of the most accurate future selection and emission reduction algorithm. This will allow the researchers to accomplish their goal of achieving the purpose of this mission was to design a new generation of data mining algorithm that have population to outperform previously published data mining techniques in the fields of social science and health care. Thank you.
Okay, thank you. Thank you very much for your presentation. Are there any questions about this presentation? Okay, if there are no questions, we can go on with the next paper. The title of the paper is Optimal Sizing and Detailed Analysis of Microgrid with Photovoltaic Panel and Battery Energy Storage System Integrated Electrical Vehicle Charging Station. If you are ready, you can share your screen and start your presentation. I guess Uğur Mert Işık will present. Are you here? He's here, but I think he cannot hear us. Okay, then we can go on with the next paper. So the title of the paper is Firefly Algorithm for Shape Reconstruction of 3D Point Clouds with Normal and Gamma Univariate Functions. Are the authors here? I guess the authors are not here. Then we can go on with the other paper. The title of the paper is Modeling of Quality Control Management Processes in the Development of Operation of VLC Systems. Are the authors here?
Hello.
Okay, you can share your screen and start your presentation.
Okay, thank you. Just a minute, please. Theme of the paper is modeling of quality control management processes in the development and operation of VLC systems. The act sets out the processes of designing, researching, and operation ready electronic equipment and in a regulatory and technologically justified way using a wide range of measuring instruments that are used both to measure the nominal electrical parameters of electroradial components and statics, and to measure the parameters of dynamic electrophysical processes in complex equipment. Control is an integral and later intensive processes of the monitoring system, which provides for control and measurement operations in the internal diagnosis system. Theoretical study of the problem, a robust quality control of VLC communications under the conditions of the statistical and certainly of system agents. The LED VLC systems is functionally designed in a material component environment, which has very wide tolerance for the technical functional ratings of the element base is subject to temperature and external passive active influences during operation. So there is a need for metrological control and quantitative assessments of the quality indicators of instrumental and methodological support for the technological operations. In this slide, we show the quality management system for the control processes of the complex system. It is represented on the first figure. It's a set of business processes that determine the functional purpose of the objects. Real objects belong to multi-parameter systems, which creates problems in quality control of the entire system as a whole. To assess the functional or consumer quality of the system, they control a certain reasonable set of indicators, both determined by each indicator and by the integral criterion of the quality of the object as a whole. The issue of the choice and justification of different indicators and the development of integral criterions are as a rule the subject of the separate study and each specific case. In the next slide, we show that our methods of research, it's expected that when collecting information, the occurrences and errors of control or monitoring are directly dependent on the measurement error. Control errors are estimated as the probabilities of false and indicated rejects, and in problems on the theory of failure reliability and are designated accordingly. Like the probabilities, it was noted above the results of control risks and depend on the system and composition of the statistical characteristics of control and control agents. The number of the all possible combinations of only distribution nodes is in compositions will be 139. A number of such combinations have already been studied and published. But the bulk of the tasks on the subject's material unexplored. And in this figure, you can see instrumental control at the most important stage of diagnosis. The diagnostic systems is based on the measurement and control procedure of the certain parameters. You see the set XI is set of indicators of the functional performance of an object and physical, economics, or social form of natural dimensions. In real situation, it's not always possible to control the selected natural indicators in existing units of measurement, and then they resort to replacing them with indirect ones informationally correlated with them, which are called diagnostics. Next slide is about quality of system processes. Is evaluated by the result of measuring each implementation from the set of parameters C and comparing the measured value with the normative. CA, the lower standard, and CV is upper standard. If the measured values goes beyond the accepted standards, this procedure is carried out in the analysis unit. In this case, we see event A and event B. Event A is case provided that the value of parameter C is not interval. Event B, the case when the measured value according to the device is below the limit value of the parameter CA. Mathematically, these probabilistic events are expected as these formulas. Events A and B are independent events, and simulations occurrence of these events, event C, in accordance which you can see in this picture. The properties of probability theory will be determined by the product of these probabilities. As a result of this research, we can see that during of each simulation modeling, they consist the process of acting out by also change in values of the current parameters of the standards C and C. Further simulation of the control process is implemented similarly, where other parameters will be changed in accordance with previously described example shown in this picture. And you can see the structure of step-by-step structure of this algorithm. In conclusion, one developed technologies, VLC technologies, based on a model of fuzzy quality control for the system support of a robotic process. An universal model for assessing and predicting errors and risk of control under the conditions of the statistical nature and standard values, simulation algorithms for assessing the quality of control under conditions of uncertainty of standard values, simulation models for predicting the quality of automatic correction of the operation models of the VLC system, and methods for optimizing business processes in the system of production and operation of VLC systems and robotic vehicles were developed in this case. Thank you for your attention.
Okay, thank you very much for your presentation. Dear participants, do you have any questions about this presentation? Okay, if there are no questions, we will go on with the previously announced paper. The title of the paper is Optimal Sizing and Detailed Analysis of Microgrid with Photovoltaic Panel and Battery Energy Storage System Integrated Vehicle Electric Vehicle Charging Station. Uğur Mert Işık will present. If you are ready, you can share your screen and start your presentation.
Hello, yes, I am. Can you hear me?
Yes, we can hear you.
All right, okay. Can you see the screen?
Yes, we can see. You can start.
All right. Hello, everyone. Thanks for having me. Let me introduce myself first. This is Uğur Mert Işık. I am an electrical engineer working at ENKA Engineering Design Center for more than 4 years. Currently, I am studying for my master's degree at Yıldız Technical University from Turkey. Today, I am going to present a study called Optimal Sizing and Detailed Analysis of Microgrid with Photovoltaic Panel and Battery Energy Storage System Integrated Electrical Vehicle Charging Station. Yes, okay. Agenda. The presentation consists of 6 sections. We will start with an introduction first, then we examine the problem definition, contributions, system description, results, and at last, we will close it with the conclusion. Fossil fuels have traditionally played a key role in powering both power generation and transportation sectors. However, the adverse environmental and economical effects on fossil fuels have driven a growing interest in utilizing renewable energy sources in microgrids. Microgrids are localized power systems that can operate independently or in conjunction with the main grid. Microgrids offer several advantages over traditional grid systems and have the potential to transform the energy landscape by incorporating renewable energy sources. One of the primary benefits of integrating renewable energy into microgrids is the reduced environmental impact. And unlike fossil fuels, renewable energy sources such as solar, wind, and hydropower generate electricity without the release of greenhouse gases or other harmful pollutants. By relying on these clean energy sources, microgrids can contribute to mitigating climate change, improving air quality, and conserving natural resources. This shift to renewable energy in microgrids aligns with global sustainability goals and helps to foster a more sustainable energy future. Another advantage of renewable energy-based microgrids is their increased resilience and reliability. By utilizing a diverse mix of renewables and energy storage technologies, microgrids can provide a reliable and uninterrupted power supply to communities, critical facilities, and remote areas. Renewable energy microgrids also offer economic benefits. By generating electricity locally, microgrids can reduce transmission and distribution loads associated with the long-distance power transmission, improving overall efficiency. Moreover, microgrids can stimulate local economic development by creating job opportunities in new renewable energy installations, maintenance, and manufacturing sectors. Problem definition. Fossil fuels have long been the primary source of energy for both transportation and power generation sectors, but their extensive use poses significant challenges and issues. These issues encompass environmental, economic, and social concerns, contributing to the global push for cleaner and more sustainable alternatives. One of the most pressing issues related to fossil fuels is their detrimental impact on the environment. When burned, fossil fuels release greenhouse gases, particularly carbon dioxide, into the atmosphere. These emissions are a major contributor to global climate change. The continued reliance on the fossil fuels exacerbates this problem and hinders efforts to mitigate climate change. The economic implications of fossil fuel dependency are also significant. Fossil fuel prices are subject to fluctuation due to various factors such as geopolitical tensions, supply disruptions, and changing market dynamics. This volatility can have adverse effects on energy prices and energy security, impacting both individuals and economies. Moreover, as fossil fuels reserves become depleted, the cost of extraction and production increases, leading to high energy costs. Furthermore, the extraction and transportation of fossil fuels can have detrimental social and environmental consequences. The extraction process, such as mining and drilling, often lead to habitat destruction, water pollution, and soil degradation. Communities living near fossil fuel extraction sites may have experienced adverse health effects. Additionally, the transportation of fossil fuels, particularly throughout pipelines and tankers, which poses risks of accidents, leaks, and spills, which can have devastating ecological and economic impacts. Recognizing these issues, there has been a global shift towards reducing reliance on fossil fuels in both the transportation and power generating sectors. The transition to clean alternatives, such as renewable energy sources like solar, wind, and hydropower, along with the electrification of transportation, holds promise for mitigating these problems. Contributions. Objectives in this work can be expressed as below. Optimal sizing of electrical vehicle charging stations, optimal sizing of the PV panels while considering both physical and financial limits, assessing the ability of the battery storage system to function as an interrupted power supply during a power failure, cost of energy and net present cost minimization, minimizing carbon emissions. Above listed objectives are executed using POMR, which is a power simulation tool that is used to design and plan renewable energy-based systems. It allows the user to input various parameters such as market availability and personal preferences to optimize the system design. System description. The objective of this work is to design a sustainable and profitable ecosystem considering renewable energy sources that ensures load demand mitigation while minimizing the cost and carbon emissions. The site ecosystem is located in Avon Park, Florida, and consists of 20 buildings with 10 apartments each. There is an electrical vehicle for each apartment, 200 electrical vehicles in total. There are 20 rooftop PV panel mounted parking stations in total, one for each building. The site ecosystem model, which is shown in the figure, consists of PV panels, utility grid, BSS, household load, EVCS, and proper size converters. PV panels installed on the rooftop of the charging station and buildings are connected to the grid. The grid, PV, and BSS collectively function as an energy source to ensure uninterrupted power supply to the load. Solar energy is converted into the DC power by the PV system, which is then transmitted to the DC bus. The DC power is subsequently transformed into AC through the converter to provide electricity to the AC load. Simultaneously, any surplus DC power generated by the PV system is stored in the BSS. In cases where the PV supply is insufficient, the BSS can step in and deliver power to the loads throughout the converter.
Mr. Işık, you have 2 minutes left. Please try to summarize and conclude your work.
Well, it seems like it will take like 5 minutes more.
Okay, please go on.
Okay. A case study is implemented to validate the proposed model. POMR optimizer calculates and compared various feasible configurations with and without system equipment such as PV panels, converter, BSS. Proposed system consists of household loads, PV panels, utility grid, electrical vehicle charging station, battery storage system, and converter. Household load characteristics. The figure shows the hourly average demand for the household loads. The maximum hourly load of the household load stays below 4.2 kilowatt and above 1 kilowatt. PV panel characteristics. The PV is modeled in POMR environment in accordance with the solar radiation data of Florida, USA. The amount of solar energy that can be converted into electricity by a PV system is limited by several factors, including the available surface area for the panels, the angle and the efficiency of the panels themselves. Flat plate PV panels are selected and design parameters that are given in the following table implement the simulation environment. Sizing of the PV system is made by POMR optimizer module. EVCS characteristics. The investigation into the power consumption characteristics of the EVCS aims to attain a reliable and optimized microgrid. The modeling of EVs simulates their role as consumers within a parking lot context. The model EVs are selected as 5 LiDAR type of cars with 40 of each model, 200 electrical vehicles in total. In addition to above EV inputs, the possibility of EVs being at the charging station shall also be considered. The percentage of parked EVs is given in the following figure. Battery storage system characteristics. The primary objective of the proposed system is to ensure a continuous supply of the required power to load. In situation where the power generation by the PV system is inadequate and to meet the load requirements, the storage system begins the discharging to supply power. By supply power, if the BSS is depleted, the grid supply is utilized as a main power source. BSS charges the batteries during off-peak hours, taking advantage of lower electricity prices, and discharges the battery during peak hours when the electricity prices are higher. This is commonly known as peak shaving. By implementing a BSS for peak shaving, it is also possible to reduce stress on the electricity grid during peak hours, which can help prevent blackouts and brownouts. Converter characteristics. Converter is the essential part of the proposed system since it provides the transmission between DC power that's supplied by PV panels and BSS. The optimum sizing of the converter is made by Homer optimizer model with considering both financial and electrical conditions. Results. Homer software measures the financial feasibility of the renewable energy systems by calculating net present cost, operating cost, and cost of energy for the proposed system. It also provides detailed energy flow such as power generation, excess, and consumption and shortage in the system. The comparison between the proposed optimized microgrid system and the base case allows us to evaluate the advantages and differences of the two system configurations. Including battery storage in the base case is primarily motivated by the existence of an annual 2-hour power outage. During the power outage, household load is being supplied by battery storage. It ensures that the system can work as an off-grid in the event of 2 hours power outage. As displayed in the figure, during the power outage, the amount of energy purchased from the utility grid hits zero and BSS is used to supply the necessary household loads. Thus, the state of charge for the BSS is decreased from 60% to 20%, which is minimum threshold level for the BSS. Once the power outage is over, the battery is recharged to restore its state of the off charge. The proposed microgrid that consists of grid connection PV, EVCS, and BSS can be analyzed under several sensitivity parameters. Electrical analysis. The main electrical advantages of the optimized system are increased reliability and demand side flexibility. The use of RES and BSS improves the overall reliability of the system. In the event of power outage or disruption in the utility grid, the microgrid can continue to provide power to critical loads. On the other hand, optimized systems energy purchase decreases significantly, especially before the evening thanks to PV panels. The optimized system takes advantage of the power generated by the PV panels during daylight hours, which reduces the need for the energy purchases from the grid. Furthermore, as demonstrated in the figure, the BSS is fully charged between 2 a.m. to 6 p.m., which provides additional reliability and flexibility to the microgrid. By storing excess energy generated by the PV panels during the day, the battery can be used to meet energy demand during periods of low or no sunlight. Initial investment cost. The initial investment costs refer to upfront and fixed costs required to implement the respective system. An optimized system has higher initial investment costs than a base system, as it often requires the more advanced technology or additional equipment to achieve its improved efficiency. Operation and maintenance costs. The optimized system will have lower operating costs than a basic case system, as it is designed to be more efficient and therefore requires less energy and resources to operate. Maintenance costs may include repair costs, replacement costs, and any other costs associated with the keeping the system in good working order. Return of investment. Finally, the ROI.
Mr. Işık, please try to conclude because we have already exceeded your time and there are other papers to be presented. Please try to summarize.
The ROI is a measure of the profitability of the respective system. An optimized system will have a higher ROI than a base system, as it is designed to be more efficient and cost-effective, resulting in higher profitability over time. Environmental analysis. The Paris Agreement, which was adopted in 2015, is a global agreement aimed at reducing greenhouse gas emissions and limiting global warming to well below 2 degrees Celsius with a target of 1.5 degrees Celsius. In addition to reducing carbon dioxide emissions, the PV-based EVCS can also help reduce sulfur dioxide and nitrogen oxide emissions, which are major contributors to air pollution. Emissions output are given for both proposed systems in the table. With considering the emission data table for both systems, it can be inferred that PV-based microgrids are plays such vital role to reducing greenhouse gas emissions and any other pollutants. Conclusion. The study introduced a model that effectively integrates PV-based EVCS and EVs to accomplish the dual goal of lowering carbon emissions in both the power generation and transportation domains. The study also suggests the use of BSS to smooth out the variability of RAS and provide the backup power supply during grid outages. The research has simulated using Homer to check its technical and economic viability. The result of the simulation showed that the proposed system can significantly reduce carbon emissions by 44%. The study also found out that the optimized system can reduce the overall system cost by 9.5%, which makes the proposed system economically viable. Thank you for your patience.
Thank you very much for your presentation. We are going on with the next paper. The title of the paper is Optimizing Variable Selection and K in the KNN Classifier with Precision Objective. If you are ready, you can share your screen.
Hello, can you hear me?
Yes, we can hear you. You can start.
Can you see the full screen?
Yes, we can see.
Okay. Good afternoon. I'm from Hong Kong, and my presentation is about variable selection and the K value in KNN classifier with precision objective. So I will directly go to introduce the motivation of this study. The KNN classifier is based on the concept of similarity of characteristics of an instance with its neighbors. So the neighbors here are the other instances with similar characteristic as the current instance. And the classification is made according to a majority voting mechanism. In other words, once the K nearest neighbors are identified, look at their classes and find which class is the majority from those K neighbors. So the advantage of KNN is that it is simple to interpret and easy to execute. There is no assumption necessary on the distribution of the data. And it has broad applications in different fields like design of a statistical process control chart, forecasting demand. In medicine, it is used in a prediction of the presence of disease or the disease progression. And in communication, it is used in filtering spam email and building a recommendation system. So the typical approach in applying the KNN classifier is usually sequential. The variables or the features are selected, and based on the data characteristics, a fixed or a dynamic value of K is determined. A distance metric is also adopted by the user, and the distance is a measure of the similarity of an instance from its neighbors. So distances are calculated in order to identify the K nearest neighbors, and finally to make the classification based on the majority voting mechanism. The relationship between selection of variables and the K value is less studied. In the literature, we have a hybrid approach of genetic algorithm and KNN proposed by Kadan. It is called biogeography-based optimization, and they will use this hybrid approach to simultaneously select the features, the weighting of the feature, and to determine the value of K. This is a meta-heuristic approach. So the motivation in this work is to explore an exact approach which can provide benchmark for performance comparison with other approaches. And it is also a continuation of my recent research, but with two other objectives, classification accuracy and recall. Another purpose of this research is that when ties occur in variable selection and or the choice of the K value, a more holistic approach would help to decide on the best combination. So in binary classification problems, we classify an instance into one of two classes. The target class is usually coded as value 1, and the non-target class is coded with value 0. So the actual class could be one of the two, and the prediction for the classification again could be one of these two. So there are 4 possible outcomes. Precision is only one of the performance measure of a classifier, and others are like classification accuracy, recall, F-score, or the area under the operating characteristic curve, AUC. Precision particularly measures the accuracy of the positive predicted incidences. So for example, if this is a problem about predicting whether a person has a disease, then the true positive are those who have the disease and are predicted to have the disease. And negative are those who do not have the disease. So precision is defined as the correct prediction out of those who have been predicted to be positive. And so according to the notation of the dependent variable y, Y hat is the predicted value, the predicted class of instance I. And the actual class is denoted by simple Y. So precision can be defined as this fractional expression among those who have been predicted to be positive. How many are accurately predicted? So this is a nonlinear function. The numerator and the denominator are linear functions of the decision Y hat, the predicted class. So we treat this as the objective in the optimization model. And to determine the variables and the best K value, the logical flow is to collect the input, the set of variables, and set an upper bound for the K value. Adopt a distance metric. In this study, we simply use the square Euclidean distance as illustration. But other distance like the Minkowski distance is also possible. The data are first pre-processed by normalization. In other words, convert the original variable into a normalized value between 0 and 1. And then the distance that is also scaled. Find the maximum distance of an instance from its neighbor, and then divide the original square distance from the maximum distance. And this will scale the original square distance into a unit scale, a value between 0 and 1. Apply a type of optimization model, which is called mixed integer linear fractional program. The fraction here refers to the precision objective, the expression of the accuracy of predicting positive instance, correctly predicting positive instance. So there are sets of decision variables, including the selection of variables and the neighborhood size. Big K is simply an equivalent form of the final neighborhood size, small k. And the solution algorithm to solve this mixed integer linear fractional program is parametric algorithm. It is one of the approach to solve mixed integer linear fractional program. And once this is solved, we get the output, the set of selected variables, the K value, and maximum precision. So
sorry, you have just 1 minute to complete your presentation. Please try to conclude.
Okay. So I will skip the solution algorithm, which is quite well known, based on Newton's method. And it is simply an iterative approach to solve the mixed integer linear program until the objective value is 0. So I will skip the mathematical details and go into the computational experiment. I apply the model on 12 publicly available data sets. What is found is that the model, when there is no requirement on the number of variables to be selected, the precision is good in the full set as well as the training set, but not so good in the test set. So I run the model 3 times. Each time I will have a different lower bound, lower limit on the number of selected variables. So the blue letters, the blue numbers represent the case when the test set precision is the best, uniquely the best. So for the 12 data sets, I run different experiments by splitting the whole data set into different training and test sets. mainly according to the ratio 80-20. So according to the experiments, you can see most of the best test set accuracy, test set precision occurs either in using all the variables or in using at least half. For small data set, when the number of variables is small, using all variables will be the best. This is very convenient when the problem size is small. So to summarize, if your objective is to maximize the precision, then using at least half of all the variables, or using at least half up to all the variables, will give the best or equally good precision in most of the experiments. And if you relax the constraint on the number of selected variables, the training set precision will improve at the expense of the test set precision. The neighborhood size K helps improve the precision in the training set when the number of selected variables is few.
General public.
And in these problems, we experience quite common. We have multiple optimal solutions. And the limitations, yes, precision. Precision could be 100% when you make very small number of positive prediction. So we will further extend our research to the measure of F-score. F-score is a more justified measure of classification performance. So to conclude, we have proposed an exact approach to select variables and the neighborhood size K in KNN classifier in order to maximize precision. The methodology is based on mixed integer linear fractional program and the use of parametric algorithm to solve the problem, to solve the model.
University campus.
And the results show that by employing between 1/2 to all variables matched with an appropriate K value can achieve the highest test set precision in most of the experiments. And we can also extend the approach to Minkowski distances as well as the performance measure of F theta score. When theta equals to 1, it is simply the F1 score, which is the harmonic mean of precision and recall. That concludes my research. Thank you for your attention, and you are welcome to ask questions.
Okay, thank you very much for your presentation. Are there any questions? Okay, I guess there are no questions. We are going on with the next paper. The title of the paper is A Proposed Secure and Efficient Big Data Security Mechanism Using Encryption Algorithm. Are the authors here? I guess the authors are not here. Then we are going on with the next paper. The title of the paper is Conceptual Design of a Multi-Sensor Based Dexterity Assessment System. I think Sena Zeybek Kılıç will present. If you are ready, you can share your screen and start.
Participant, thank you for attending to my presentation. I am Sena Zeybek Kılıç. I am a master's student in the Department of Intelligent System Engineering at Barton University. In this presentation, I will talk about our study. Our study is conceptual design of a multi-sensor based dexterity assessment system. Evolution of manual dexterity is very important in determining the hand functionality and degree of limitation in activities of daily diving. Various tests have been developed for the assessment of manual dexterity during the application of the
of this test, there is an expert who determines the duration for each movement while the participant performs standardized tests. This leads to patients being given appointment days later, especially in overpopulated cities. In addition, various error may occur due to the human factor in the measurement. The Minnesota dexterity test is widely used to measure unilateral and bilateral growth, fine manual dexterity, and to monitor the patient's progress in the rehabilitation process after illness and injury. In this test, there are 60 discs and a test board on which these discs will be placed. One surface of the disc is black and the other surface is red. In the test procedure, the disc must be placed in certain order and sequence. There are two phases in the test. In the placing phase, 60 discs are placed in front of the test board away from the subject. The subject is asked to place the disc in certain order in the space on the board. In the turning phase, the subject is asked to pick up the disc with one hand, rotate them with the other hand, and return the disc to its original place. The subject is informed that time is important and asked to complete the phases as soon as possible. In this diagram, details about test setup, sensors, methods, and working principle of the success system is given. The system uses Raspberry Pi 4 Module B as the control hardware and is built in Python software language. During the Minnesota dexterity test, the system uses EMG data to classify peak place motion, IMU data to detect arm position and velocity, and camera to detect the disc position and orientation. In this system, muscle contraction levels and leg position and orientation, which are among the measurements required to automatically determine the dexterity score, are obtained with the Moyo armband device, which has an 8-channel EMG sensor and a 9-axis IMU sensor. In the dexterity determination phase, the peak and place moments are determined by measuring the muscle contraction levels on the forearm. At the same time, the position and orientation of the arm is obtained with the IMU sensor on the armband. Muscle contraction levels measured by EMG are evaluated with the artificial neural network-based log linearization Gaussian mixture model network algorithm developed by Tushu et al. And movement classification is performed. This position and orientation, the Raspberry Pi camera module is used to detect the orientation of the disc according to their position and color. The image obtained with the camera are evaluated with the color recognition and shape detection algorithm of OpenCV image processing library. With the color recognition algorithm, the black and red colors on the disc surface are detected and the orientation of the disc is determined. The disc positions are determined by calculating the distance of the disc centers to a reference point on the scaled background. The moment function determines the moment point of this drawn circle, the center coordinates of the disc. Personal information about the individual being tested is entered through this interface. In addition, the instruction to be considered recording the test are shown the subject as a video. The sickle score calculated at the end of the test is also shown through the interface. The expert system rule base contains information about the evaluation of the person's condition according to the measurement obtained in the dexterity test. At the end of the test, the dexterity score is obtained by evaluating the measurements. Moment classification, determination, and times related to position, velocity, and orientation according to this rule base. The successive system outputs various additional parameters in addition to the total test duration, which is used as an evaluation parameter in existing test methods. Free thinking time is the time elapsed when there is no disk in the subject hand and the arm is stationary. Thinking time with disk, it is the time when the subject has a disk in the hand and the arm is stationary. Time to reach disk, the time elapsed when there is no disk in subject hand and the arm is moving. Displacement time, it is time elapsed when the subject has a disk in the hand and the arm is moving. Total number of disk drop, in the system, the entire test area is scanned continuously with the camera and position and orientation of the disk are determined. Disk turning time, in the Minnesota test, the task is to turn the disk according to their upward facing side and place them back in their original position. Conclusion. In the study, a system that automatically performs the necessary measurements and evaluation during the hand dexterity test with multiple sensors is proposed. During the hand dexterity test, muscle contraction level and movement classification are performed. Joint and limb position and orientation are measured and recorded. Their performance in performing test is determined by image processing. That dexterity score is calculated with the obtained data and a result recording the dexterity level of the subjects related with an expert system-based structure. In this way, the workload of the clinicians is reduced, the number of daily patient admission is increased, and objective and accurate measurements are realized. In future studies, the proposed system will be implemented and tests will be performed with healthy and patient subjects. Thank you for listening to me.
Okay, thank you very much for your presentation. Dear participants, do you have any questions about this topic? Okay, I guess there are no questions. We can go on with the next paper. The title of the paper is Maintenance Scheduling Optimization Using Artificial Intelligence Techniques, a Review. If you are ready, you can start. I think Azil Jamil will present. Can you hear me? We can't hear you.
Okay, good afternoon, everybody. I'm
Okay.
Azil Jamil. I'm PhD candidate in Department of Production Engineering and Metallurgy at University of Technology, Baghdad, Iraq. And I will present my paper entitled Maintenance Scheduling Optimization Using Artificial Intelligence Techniques, a Review. First, the outline of the presentations as a fellow introduction, research methodology, optimization algorithms, results, and conclusions, and future works. Introduction, maintenance is defined as the combination of all technical and associated administrative actions intended to prevent a device or component from failing or restore it to a state in which it can perform its required functions. The maintenance scheduling problem is highly a constrained combinatorial optimization problem, and proper optimization tools are required to determine the best feasible maintenance schedule. A wide range of artificial intelligence techniques has been employed to handle the difficulties in maintenance scheduling. Many maintenance problems can be viewed as an optimization problem for which computational intelligence techniques might be beneficial compared to the mathematical approaches, which has difficulties, especially when time efficiency is an important issue. Research methodology. Since it's very difficult to conduct a global search because the interesting topics have been scattered across many sources, we adopted the following searching method based on 3 sets of databases, including IEEE Explorer, Springer Link, and Science Direct for the time frame from 2010 to 2022. The search was made by specific term to establish comprehensive references on maintenance scheduling optimization. And the first step, the viewer search based on descriptor maintenance scheduling optimization, which originally produced 130 publications, 16 in the IEEE Explorer database, 74 in the Science Direct database, and 40 in the Springer Link database. Then the full text for each publication has been carefully examined to exclude those that did not match the required search criteria. In the end, the search led to the 37 publications on selected topic. Optimization algorithms. Optimization is the process of finding the best solution to a problem by either minimizing or maximizing value of an objective or using single or multi-objective function. Objective functions are the performance indicators against which an optimization problem is solved. For multi-objective, there are 2 methods that make the problem simple and do not need for complicated mathematical equations. These methods are scalarization and Pareto. In scalarization method, the multi-objective function made into a single solution using weight. Meanwhile, in Pareto method, there is a dominant and non-dominant solution created by continuously update algorithm. Optimization algorithms can be divided in 2 categories based on the produced solution, namely deterministic and stochastic algorithms. It was reported recently that the stochastic algorithms have been applied in solving maintenance scheduling problems that are very close to optimality in an acceptable computational time. Stochastic optimization algorithms, which are of 2 types, heuristic and meta-heuristic algorithms. The meta-heuristic algorithms divided in 2 groups, namely the trajectory-based meta-heuristic, in which the problem solution iteratively modified over a number of iterations of the algorithms by moving from single solution to another single solution through the search space, such as local search, simulation annealing, and tuple search. For population-based meta-heuristic, used a population of solutions that are iteratively modified at the same time. Population-based meta-heuristic comprise evolutionary algorithms such as genetic algorithm, evolutionary programming, and differential evolution. And the swarm intelligence such as particle swarm optimization, artificial bee colony, and ant colony optimization. The results, many researchers have implemented several heuristics and meta-heuristics algorithms to solve maintenance scheduling problems in different application sectors. For the figure 1, that display the optimization algorithms and show the frequency of the optimization algorithms, we can note that 31% of the paper used the genetic algorithms, followed by 22% used the hybrid algorithms. While for the second figure, to the application sector, 47% of the published paper applied to the power plant. And finally, the maintenance and the failure costs were the most desired objective with 53%. Conclusion and future works. The work revealed that the most literature is interesting in power plant maintenance scheduling problem, which is made up of many complex machinery and equipment due to the tendency to degenerate over the time. Genetic algorithm is the most common artificial intelligence technique applied in maintenance schedule due to its nature and provides a powerful optimization tool that can be handle the difficulties in maintenance scheduling problem. The hybrid approach involves the combination of various algorithms is presently the utmost successful and effective trend in AI optimization, which improve the search computational speed. The limitation of this word search restricted to the 3 database. So we suggested expanding the search to include other databases for the future work. Also, with the higher increase in the data and information technology, combine the Internet of Things and AI techniques to improve the maintenance scheduling optimization can be covered for the future work. Thank you for your attention.
Okay, thank you very much for your presentation. I guess you have
Thank
one
you,
more
sir.
paper to present.
That's right.
Okay, you can present your second paper.
Okay.
We are waiting for you.
Just a minute. It's okay.
Yes, you can start.
Okay. My second paper entitled Fuzzy-Based Preventive Maintenance Priorities with Safety Consideration for a Power Plant. The outline of the presents as follows: introduction, research methodology, robust fuzzy model, validation and testing, and finally conclusion and future work. Introduction: maintaining complex system has become more difficult in recent decades. This is due to the fact that the systems are made up of many interconnected components, and the breakdown of a component results in system downtime and unplanned shutdown of other components, as well as the expense of replacing it immediately. In modern power systems, the demand for energy has risen significantly with related expansion in power system size, which has resulting in higher number of generation units and lower reserve margins, creating the generating maintenance scheduling problem. Generator maintenance scheduling a power plant must meet the electricity demand while also ensuring the system safety and reliability. The research methodology. The main purpose of the proposed fuzzy model is to assist maintenance team in selecting the best maintenance priority for generation units. The expertise of experts incorporating the system with the other knowledge source from a power plant maintenance logo book and failure historical. The framework of the research methodology, as shown, include phase 1 data collection and analysis, identify maintenance priority effective factor, and use the historical data and expert judgment. Phase 2 with modeling approach, we'll use the fuzzy logic, triangular membership function, and Mohammedani fuzzy interface system. And the third phase, application and the results. The proposed fuzzy model for crisp inputs corresponding to the maintenance priority effective factors were considered in this model. The first input is failure severity. 3 types of failure severity specified based on possible influence of a particular failure on system performance. There are as the follow. The first step that include first type of the failure severity have the high severity and with a crisp range 55 to 100, which is the result in forced stop of the units, potentially causing damage to the unit's component and also reducing generating unit life. The second type of the failure have the medium severity with a range 20 to 60, when the occur does not result in forced stop of units and it can be fixed as a normal shutdown. And the third type have the low severity when its occur does not lead to stopping the generating unit, which can be fixed and the unit is still work. Safety, this is the second input factor for the fuzzy model. A potential failure of an equipment can result in injury or even death of the workers. This factor is considered very important to conduct the risk. 3 harm severity levels are considered. First level, with the extreme harm at the rate 60 to 100. The second level will moderate harm with the range 30 to 70, and the third level slight harm with the range 0 to 40 level. The third inputs include the downtime. The downtime is represent the average time that an equipment is not functional due to the potential failure, or there are three outage time levels are considered with the range of the downtime per 1 year. The first level consider high and with the range 18 to 45 days. The second level medium with the range 8 to 20 days, and the third level low with the range 0 to 10 days. And the last onboard the frequency of the failure, which represent the number of failures such as breakdown per the specified period. Also, we consider three levels. The first level high with the range 20 to 40 breakdown, frequency failure. Second level medium with the range 10 to 25, and the third level low with the range 0 to 15. Classification and inference process. MATLAB Fuzzy Logic Toolbox was used to build the fuzzy inferences system for the maintenance priority. Through the use of a membership function, the fuzzification process converted the crisp input into linguistic terms. Triangular fuzzy membership function were chosen to represent the fuzzy failure of the system components due to its simplicity and good performance in the reliability engineering. And this figure represented the membership function for the first input, the failure severity, and this one, the membership function for the second input, the harm severity. The third figure is for the downtime, and the fourth one for the failure frequency. The inferences process converted the fuzzy input value to fuzzy input value to fuzzy output value by applying a set of rules. A simple logic combined expert opinion is used to construct a rule, and a total of 81 rules are formed with the three fuzzy variables and the output variable, which is a maintenance priority. For the fuzzification, the inferences process, the overall results must be defuzzified to obtain the final crisp output. Triangular membership functions with three levels, high, medium, and low, are also considered for the output variables, while the center of gravity method is used for the fuzzification. Validation and the testing. In order to validate and test the proposed fuzzy model, a real data set, which is a concerned gas power plant, was used as shown in the table. The assigned value of the input variable for 14 generating units and their resulting maintenance priorities. According to the results, the units 1, 3, and 6 have the same priority output, and they are ranked firstly, and the unit 4 and 13 both had the same priority output and were ranked lastly. The other units 7, 8, 2, 10, 9, 5, 12, 11, and 14 got second to 10th priority respectively. Conclusions on the future works. The using of a fuzzy logic provided opportunity to cover a wide range of judgment, including vagueness, which resulted in different parameters valuation outcomes compared to other attempting using non-fuzzy methods such as failure mode and effective analysis. Safety data are frequently critical for decision-making and must not be discarded. Fuzzy approach provided a particular solution for maintenance priority problems, especially when there is a lack in availability of safety real data by analyzing failure severity on health and safety harm. The use of fuzzy rules allow the experts to revise or update the model when more information are available, and the overlap between the adjacent membership functions to provide a smooth interpolation of the input across membership functions. And for the future work, a possible direction for the future work is establish an efficient approach to develop the membership function using the data-driven models such as artificial neural network. Thank you for your attention.
Okay, thank you very much for your presentation.
Thank you.
We have 3 more papers, but the authors were not here. Let me once again announce them. So The title of the paper is Distributed Optimization Algorithm for Resource Allocation in MIMO Network with Intelligent Reflective Surfaces. Are the authors here?
Yes, I am here.
Okay, you can share your screen and start your presentation. You have 10 minutes to present your work.
Hello, my name is Afnan. I am a master's student in Istanbul Okan University. Today I'm going to work my present, I'm present to my work, channel performance optimization based antenna array, MIMO design using intelligent reflecting surface. The IRS structure basically are theoretical structure based on 2D planar array that can be controlled within a FPGA controller to steer the radiation of electromagnetic beam toward a certain direction. IRS consists of two main layers, the hardware and software layer. The hardware layer can be classified into the configurable metamaterial unit cell structure and meta surface array. The surface of software layer is based on artificial intelligence network, including neural network or any other types of network. So the material can be engineered to provide certain permittivity, permeability, and design frequency bandwidth, and can be miniaturized to a small size and provide zero reflective index. This can be controlled by the controlling the L and the C parameters of their unit cell within certain switches, including pin diode, particle diode, and optical resistor. Now, here is some example of switches, including pin diode, particle diode, and other types of switches. The meta surface basically works are reflector that control the reflection from the source toward a certain direction, including, for example, the user. So there is an obstacle from the transmitter to the receiver directly. This can be controlled by RIS. The element of obstacle, so the direction of the signal can be controlled by directly from the receiver to the transmitter. The ability of the controlling the reflection can be obtained using certain algorithm, including CNN or NN or any other kind of game theory algorithm. For your information, the meta surface or RIS structure can be embedded in buildings in symmetry that's no significant effect like this, or can embedded in walls of buildings. Here in our study, we proposed design Bauti fractal antenna to be controlled by the location when a switch is located as at a middle of the Bauti, and we study for that the surface field distribution. We found smoothly without airway variation or symmetry between the edge of the structure. Now let's look at the channel capacity of Shannon theorem equation that says the bandwidth of a unit cell multiplied by n number of channel times log 1 plus SNR. From this equation, we have a very obvious answer that increase in the bandwidth can increase the channel capacity. Also, the number of elements can increase the channel capacity. Now we use the millimeter wave for the technology. However, the issue with millimeter propagation effect, before we go ahead with this design, we found the propagation for almost frequency band up to 22 up to 28 goes within 50 meters with acceptable attenuation factor. Now we study the individual unit cell developments. The applied study on the S11 parameter, we found that the S11 parameter shows frequency bands from 24.7 gigahertz up to 27.3 gigahertz, which about 2.5 gigahertz with the good gain 26 gigahertz, well 7.8. And the radiation of the antenna on individual unit cell is almost directional, zero plan, and very detective in the 90 plan. Now we study the effect of beam steering. We apply this study and we found that the radiation of the antenna goes from minus 26 to plus 26 degree. So this is good for literature, and we can detect many users within a range of this beam width. Therefore, the beam width of that antenna array at 0, plus minus 13 degree, plus minus 26 degree, we found the phase is good or mostly symmetric, and also the distribution of magnitude is symmetric over the entire frequency band. That motivates us to study the channel capacity for 3 types of configuration: 16 by 16, 32 by 32, 64 by 64. We found the channel capacity increased with increasing the number of elements, that is similar to the results in the channel capacity. Also, bit error rate is decreased directly with increasing the number of unit cell elements. In the conclusion, to
I guess connection is lost. Okay, dear participants, we have 2 more papers. Before that, Afnan Ram, are you here?
hello, I am here. Yes.
Did you finish your presentation?
Yes. What is the?
Okay. Thank you. Thank you very much for your presentation.
Thank you very much.
We have 2 more papers. The authors were not here. Let me announce them. The title of the paper is Firefly Algorithm for Shape Reconstruction of 3D Point Clouds with Normal and Gamma Univariate Functions. Are the authors here? Okay, they are not here. And the other one is a proposed secure and efficient big data security mechanism using encryption algorithm. Are the authors here? Okay, I guess the authors are not here. On behalf of organizing committee, I would like to thank you for your scientific contribution to the Congress. We are now ending this session. Thank you very much.